Now we have the function f of x equals x squared plus 5x plus 6. And we ask, where is this function increasing, where is it decreasing, and where does it have a relative maximum or minimum? Now, a little illumination of that terminology, relative maximum or minimum. If we've got a graph that looks like this, then it has a relative maximum here and a relative maximum here. It's a point that's higher than any other point nearby. A relative minimum here. Again, a point that's lower than any other point nearby. Now, this is clearly not what we call a global maximum. It's not the highest value this function has, but it's higher than any value close by. This one could be the highest value, the peak of the whole function. We don't know. It might extend this way, and there might be more to the function. But if this is all there is, then this would be the maximum. We would call that the global maximum. But both this and this would be relative maxima. This is clearly not the minimum, the global minimum. There are points over here and points over here that are lower than this one. The one thing we do observe about a relative max or relative minimum is that the slope of the tangent line at that point is always horizontal. If the slope wasn't horizontal, then the function would either be increasing or decreasing. And either way, if it's increasing, then there's a higher point just to the right of it. If it's decreasing, there was a higher point just to the left of it. And there is another way the slope can be zero. So if the slope is zero, that doesn't mean that we have either relative max or relative min. The function can come down and level off just for an instant and then turn and decrease again. There's a slope zero, but it's not a relative max or relative min. So that's what we mean by relative maximum or relative minimum. So to figure out where the function is increasing, well, what does it mean for the function to be increasing at a point? That means basically its tangent line is going to have a positive slope. Now, how do we get the slope of the tangent line? Well, as we've just seen, the slope of the tangent line is equal to the value of the derivative. So if the tangent line has positive slope, that means the derivative has to be positive. So if the function is increasing, the derivative is positive since the tangent line has a positive slope where f is increasing. Okay, where is it decreasing? Well, it's decreasing where the derivative is less than zero because, again, the derivative is the slope of the tangent line. And if the derivative is negative, that means the function is decreasing. If the tangent line has a negative slope, the function is decreasing, therefore the derivative is decreasing. And relative maximum or minimum occurs when the derivative is zero, since in that case the tangent line would be horizontal and the slope of a horizontal line is zero. Okay, so in order to apply this to the function f of x equals x squared plus 5x plus 6, well, we have a test involving derivatives. Excuse me. Don't know if you could tell I was getting all choked up. Derivatives do that to me. No, allergy season, actually. Okay. Okay, f prime of x, then, well, that's easy to calculate. It's 2x plus 5. Okay? Now, f prime of x is greater than 0 if and only if 2x plus 5 is greater than 0, which is true if and only if x equals negative 5 halves, as we can easily determine by solving the equation. So f of x is increasing as long as x is greater than negative 5 halves because, again, the derivative is greater than 0 whenever x is greater than negative 5 halves. So that we'd say the function is increasing on the open interval from negative 5 halves to infinity. Okay? Now, where's the derivative of f prime of x less than 0? Well, we take the expression for the derivative, and we form the inequality, that expression less than 0, and solve the inequality, which can be done in about one step and very easily. And we get x less than negative 5 halves. So it follows that the function is decreasing whenever x is less than negative 5 halves, and that occurs on the interval from negative infinity to negative 5 halves. So we have the criterion for the function to be decreasing. And then where do we have a relative max or min? Well, that's going to occur at if you have a relative max or min, then the derivative has to be 0. Now, we're going to find that the derivative is 0 at x equals negative 5 halves, just what we would expect, setting the expression for the derivative equal to 0. That does not mean that there is a relative max or min at that point. It just means that it's possible to have a relative max or min at that point. Remember, we can have slope 0, we can have the derivative equal to 0 at a point like this. That is not a relative max or relative min. So, all we've determined so far is that you could have that a relative max or relative min is possible. Okay, when x is negative 5 halves. Now, if we put all this together, we can conclude whether there's a relative max or relative min at x equals negative 5 halves. The interval negative infinity to negative 5 halves on a graph would lie to the left of x equals negative 5 halves, and the function would be decreasing to the left of x equals negative 5 halves. So to the left of this value, the function is decreasing. So if negative 5 halves is here, the function is decreasing all the way up to negative 5 halves, and then the function, the derivative, well, yeah, the function is decreasing because the derivative is negative all the way up to negative 5 halves, and then the derivative is 0, meaning that the function has leveled off. And then immediately, you're to the right of 5 halves, and the function is increasing again. Now, if the function is decreasing, then it's level, then it's increasing. That means you have a relative min. So by putting the information together, function is decreasing to the left, it's level, it's increasing to the right. You do determine that negative 5 halves is a relative minimum. So I can indicate that like so. We're decreasing to the left of negative 5 halves, increasing to the right, and level at excuse me, negative 5 halves. And I don't have a lot of room to sketch functions, but here's a function whose graph is decreasing up to negative 5 halves, then it levels off just for the instant at negative 5 halves, then it increases. Now, the function doesn't necessarily look like this one. It might be narrower, it might be fatter, it might come down very quickly, level off, then go up very, very gradually. It might be higher, it might be lower, but along the line x equals negative 5 halves, wherever the graph meets that line, it's going to be level.